Welcome to Study Loop.
Problem we can first use equation 23.8 to find out the object distance for different image distances. So we have two different scenarios where in the first case our image is at infinity and our focal point is always same, which is 12 centimeter. So if we want to use this equation, we have 1 over d0 plus 1 over di, that's the image distance, which is equal to 1 over focal point. And since so let's call it case 1, when the image is at infinity, right? So from here, if we try to solve for d0, we see that this part is in 1 over infinity, so this becomes 0. So we have 1 over do, which is equal to 1 over f, and since f is 12 centimeter, so do becomes f, which is equal to, since focal length is 12 centimeters, so the object, distance of the object would be 12 centimeters. Right. Now, if we use the second case, so for the second case, our image is at near point, which is 25 centimeters. So image is at 25 centimeters. That means that our di is 25 and focal length is 12 centimeter again. Now if we again try to solve for this, we'll have 1 over do over 1 over di, which is equal to 1 over f. From here, f is equal to, we're solving for object distance, so do is equal to di over f di minus f. And if we plug in the numbers, now the thing is, since it's a near point, since the image is forming 25 centimeters behind, in the direction where the object is, because it's magnifying, so we'll have a negative sign over here. Then we have 12 centimeter divided by negative 25 centimeter minus 12 centimeter, and that gives us a focal object distance of 8.1 centimeter. Okay, so now we know that where the object will be if we know the image distance. Now the question is whether the lens is moving toward the fine print, or is it moving away from the fine print. So to do so, we can consult this diagram over here. So let's say these green dots are the focal points, and this is the convex lens. Now in this scenario where the object distance is less than the focal point, we drew it over here. So here, this part is 8.1 centimeter, and because of that, we are getting an image distance of 25 centimeter. And if the object is shifted to infinity, so if the object is shifted to the focal point, so this is the focal point, so let's mark that down. Right, so that's our focal point, 12 centimeters. So if the object is moved to the focal point, then the image will be at infinity, right? So that means that we are getting closer to the fine print if we want to see the object at 25 centimeter, because we need to bring our lens forward so that the focal point shifts. So initially the lens will be around here, when so that the object is at focal point, and then we'll see the image. But then when we shift the lens around this region, then the object will be at 8.1 centimeter and the focal point will shift to this point. So initially it will be here and then it shifted to that part, and that means we'll be getting closer to the fine print. And that the amount which the lens will move is the difference between 12 and 8.1. So it's going to be 12 centimeter minus 8.1 centimeter, which is equal to 3.9 centimeter. And by the explanation we can say that it's moving toward the fine print. Thank you.